right now, I want you to just sit back, listen to the video once, maybe even listen to it twice, and see if this is starting to make sense. H of x has an input. Whatever's in that parentheses, that is like who's coming to the door. So maybe you can look at this as H is the person in charge of rations, and the X's come in and they say who's there, and H says, here's your ration. You're getting this number. I'd hate to get the negative ones because that means they're taking away your rations. But anyway, so what happens is the number 2 walks up to the desk where H is sitting. H asks, what are you? X says, I am -2. H says, I give you -1. That is your ration. Then -1 walks up. H says, who's coming here? -1 is. And H says, I give you your ration of 0. Ha! And I can keep going on with the same scenario. What you want to realize is H is still H. H is not changing. What is inputted in it gives it a particular output. So H is now only accepting whoever walks in as a 2x. It's not, if X comes walking up at the door, it's going to be like, wrong terminal, you need to go over there. So you want to see that when 2x is -2, it goes up to the table where H is giving the rations. H says, 2x, what are you? And it says, I'm -2. And it says, here's your rations, -1, that's what you get. And then the next one in line is 2x being -1. So H says, 2x, what are you? It says, I'm -1. H says, well, I'm giving you 0. Because that is simply what H does. If H sits at the table where X comes in, then X says, I'm -1. H says, you get -1. If X comes in as -1, H says, I give you 0. Now, what you want to understand about the graphs of these functions, when I go to graph H of 2x, this X column right here represents these numbers on the x-axis, and it is the X input, regardless of what H asks to, who H is seeing at this moment. To get this column based off of 2x, you want to look at if 2x is equal to -2, what is x equal to? -1. If 2x is equal to -1, what does that make x? -1/2. If you like, -0.5. Same thing. Make sure that decimal point's obvious. Now, if 2x is equal to 0, x is 0. That's an interesting pair right there. When 2x is equal to 1, x is equal to 1/2, or maybe you want to write 0.5. When 2x is equal to 2, oh, it won't stay there. When 2x is equal to 2, what is x? X is 1. When 2x is equal to 3, x is 3/2, or 1.5. And when 2x is equal to 4, x is equal to 2. So here's what's happening. And I'm going to highlight what I'm working through. X walks into a function. Actually, no, X doesn't get to walk into a function yet. X walks into some shady fellow 2X. And it's forced to become 2X before it can enter the kingdom of H. This -1 is doubled into -2. Now, whatever goes into H, this column here is telling me for these particular inputs, I know their outputs. We don't know anything else based on the graph, based on the table. Just if this is who enters, this is who you get. So that -1 gets doubled to -2. -2 is what's going into the H function. H is going to give it -1. So I'm going to plot that point. When X is -1, the value of H of 2X is -1. And I'm plotting that point. Next. When X is -1/2, -0.5, let me first of all point out to you who that is. -0.5 is right here on the x-axis. I don't know if you could see that, so let me just draw a nice little arrow there. That is X equals -1/2 on the x-axis. H of 2X is not accepting X's today. So it has to first be doubled. When I multiply -1/2 by 2, I get -1. -1 is the one who gets to enter the H function. Now H says if -1 enters, I give it 0. Now this gives me a point at X equals 1/2. Or I'm sorry, at X equals -1/2. And I'm going to plot that point. -0.5 for the input, 0 for the output. X is -0.5, 0 is the Y, right there on the x-axis. Before I go on, I'm going to make my life a little bit easier by doing some cut and paste. I'm going to go over to the answer column and put that in so that I can erase things more easily. Wait, I just messed up. There we go. Okay, copy is what I want to do, not paste. Come on. Okay, you don't want to pay attention to me right now. And this is, I suppose, oh, I know exactly what the thing is. I have to push select. Now it will let me go. Okay. You know what? I'll just leave those red right now. That might help a little bit. Now, back to drawing. Let me move my cursor over there. All right. Draw. All right. I've got 2 points dealt with. Next, X equals 0. Now, when x equals 0 comes along and it's forced to double itself before entering the kingdom of h, it doubles itself to itself. So 0 gets to walk in as itself, but doubled, so itself, and h gives it 1. This is the 1 point. Your y-intercept will not change when you are multiplying x by a number, because it doesn't matter what you multiply 0 by, it's gonna be 0, and 0 goes into h as 0. Whether it's 2 times 0, 3 times 0, doesn't matter. Next, when x is equal to 1/2, which would basically be 0.5, what I want to first do is emphasize, where is that x coordinate? Right here. Here is x equals 1/2. So 1/2 comes in and finds its doubling day to be able to see h. So it multiplies by 2 and it becomes 1. And h sees that 1 go in. And if it sees 1 come into its kingdom, it will give it the number 2, which is one's ration, I suppose, if you want to think about it. So that means that if I take that middle person out of the way, that I get a point to plot on the graph of h of 2x, and that is x coordinate 1/2 with y coordinate 2. Right there. I'm going to keep going. Keep listening. The more you pay attention, this is going to possibly suddenly make sense with one of these as we go along. I need to erase this. Okay. This time, 1 enters the room. I want to emphasize where x equals 1 is located, right here. That x value of 1 is doubled to become 2, and that 2 is who has to go into the h function. So the input for h, 2, comes along, and h says, I give you 0. And I suppose that 1 walks away sad because it has nothing. Now I will plot the point 1, 0. Let me erase this prep work right here. So I can plot the point x equals 1, y equals 0, right there. Now I'm going to move on, erase what I've got. Next, 3/2. 3/2 comes in as an x coordinate. As an x coordinate, it is located right there, right in between 1 and 2. It is doubled. 3/2 times 2 gives me 3. Whatever h of x has in that parentheses is who it's taking. When it sees 3 walk in, it says you get -2. I'm going to erase this big arrow for the x coordinate. And now I'm going to plot the point when x is 3/2. The y value is -2. 3/2 -2 is way down here. I'm going to erase those. And we're finally on the last one. X = 2 walks in. According to this graph, when x comes in as a 2, this is its location. No matter what happens to it, that's where it's starting. However, in order to enter the H kingdom, it must be first doubled. H then says, "Who's come to my town?" And it says, "I'm 4, coming right in." H says, "I give you -4. And now I'm going to plot that point. When x = 2 goes in, -4 comes out. Now that was just on a point-by-point basis. If I took the entire graph of h of x and looked at how it changes when I ask you, well, what does h of 2x look like? What it has to go through is it has to look at its inputs are actually double what they normally are. Now, oddly, what that actually ends up doing is when you look at the graph, you have to compensate for x having doubled before coming to you. You need to look at the parent graph's x coordinates. So I'm going to highlight the parent graph. On the left end, the x coordinate is -2. However, in order for -2 to enter the kingdom, it had to be doubled first to even enter. So you actually need to take that x value of -2 and divide it by 2 to find out who originally came in to ask, what is my y coordinate? So bottom line, what happens is when you have h of 2x, when you know the graph of h, you're going to not multiply your x by 2. You're going to divide your x's by 2. You will keep the y values as they originally are in the function, but x has to be divided by 2 to find out who went in the first place to get doubled to even see the h kingdom and what is h going to allow me to have as a y value. So what it's doing is it is horizontally compressing the graph by dividing each x coordinate you currently have by 2. Any guesses on what's going to happen when we tell h to accept only x divided by 2? In order to show you this, I'm going to cut out number 6 so I can nicely show you with this problem. If I'm not able to edit this video, you may want to fast forward through me sitting here, erasing things out. And I'm just completely getting rid of all of it. Erase. Again, I am probably going to first put this video up without the editing. You're going to have to probably fast forward through this time where I'm trying to prep for the next problem. Okay, that's right. I have to go back to draw. And I have to say select. And now it will let me do something with these. I'm going to cut them out. Bring this up as close as I can and be able to see this on one screen. Okay. So if you fast forwarded, now is the time to come back. Come back, come back. What I want you to see this time is we have this same set of y values for h of x. Like before, we have the issue of, in this table, x over 2 is coming in to find out what h will grant it. Whereas up here in this table, x is the one who walks in and h looks at x and gives it a y. You need whatever sits here to match what is going into the h function. X over 2 matches this x over 2. That means that these two columns are going to be side by side here. I just need whatever h says it's taking for its input to be who gets the input. You may want to fast forward again right here while I erase, and then I'm going to grab some stuff so that I do not have to waste as much time. And I am going to take these x values, which I could have gotten from right there. Come on. Oh, that's right. Select. Paste. So these x values are now in the column for x over 2, so that their corresponding y values go into the h of x over 2 column. If x divided by 2 is negative 2, what was x to begin with? Well, I need to multiply by 2, and I get negative 4. If x over 2 is equal to negative 1, to find out what x was, I need to multiply both sides by 2. And we're going to keep going. 0. Magical 0. If x divided by 2 is equal to 0, what is x? Ha ha! You can divide me by anything you want other than 0, but you can't do that here. You can multiply me by any positive or negative number. I'm going to be 0 either way, and I will stay here. Which is why this point right here is being forced to stay when I graph h of x divided by 2. All right, now, if x over 2 is equal to 1, what does x need to be? Multiply both sides by 2. If x divided by 2 is equal to 2, what does x have to be? Multiply by 2, get 4. If x is 3, or I'm sorry, if x over 2 is 3, what does x need to be? It needs to be 6. If x divided by 2 is equal to 4, x has to be 8. Now, in order to save some time, I am going to paste these numbers in from the answer key so that I can write and erase at will. You can fast forward while I erase until I reach the time where I can edit the video, which could be next summer. Yeah, that's where I'm looking at the next time I have time. Or actually just whenever the next break is, but then I'm probably just going to be sitting around going and recovering from online education. Yeah, that's right. Select. Now I can put things in. Paste. What did I do? I messed up. I know exactly what I did. And unfortunately, you're going to have to sit through this video until I get to the point of I want to copy of editing. Paste. There we go. And I'll just keep those red because it kind of shows why I'm the one coming in. And now I need to put my cursor somewhere else in order to make this work. Moving my cursor elsewhere. All right. So here's what happens. X equals -4 is walking in. Here's -4. Before it reaches the kingdom of H, where H decides what rations it will give to the incoming number, it is forced to be divided by 2 in order to enter the kingdom of H. So that -4 is divided by 2 and it becomes -2. Then the function h of, I'm only taking x over 2's today, looks at the number walking up, and the number walking up is not -4, it is -2. When -2 comes into the kingdom of H, H says, who goes there? And it says, I'm -2. And H says, I give you -1. Now go away. So what ultimately is happening here is the x-coordinate -4 starts this process, and the end result is -1. That means I can plot the point -4, -1. X equals -4, y equals -1. And notice that it used to be over here. Do you see that x doubled? And now I'm erasing away. -2 comes strutting in. So here's x equals -2, and it wants to know what it's going to get. But today, the kingdom of H is not accepting x's. It's only accepting x over 2's. So it has to go and find out, all right, what am I if you divide me by 2? Oh, -1, huh? All right. And then H says, who goes there? It's -1. I give you 0. So when I go to plot that point, x is -2, and I get as a final output 0, this point right here. Now, do you remember why I drew this blue point already? Because 0 comes in on the scene, says, go ahead, divide me by 2. I dare you. And it stays itself. So it actually gets to go to the kingdom of H to find out who H will allow it to have as itself. And H says, who goes there? 0. I give 0 the answer of 1. So now I have x coordinate 0, y coordinate 1 is plotted right there, which is no change from x coordinate 0, y coordinate 1 on the original h of x graph, which is this graph along here, duplicated from over here. Now, it's time to fast forward, or for me, later, edit here. Take this out so people don't have to watch me erase. Next, 2 steps up. X equals 2 is located here. The kingdom of H is not taking x's today, it's taking x over 2. So x walks in and says, fine, cut me in half. Ouch. And then h of x over 2 says, who goes there? And the number 1 is the one coming in. And it will say, if you're one coming in, I give you 2. But ultimately, that x over 2 isn't seen on the graph. I only see that 2 came in and 2 comes out. And very importantly, I want you to notice that this is coming from this point right here, where where the graph peaks. Originally on the h function, this came from putting 1 into the function and 2 came out. Before putting in 1, we got numbers out that were less than 2. After looking at x equals 1, we got numbers that were smaller than 2. Well, now I have to look at who originally came in before they were halved. 2 had to come in order to get halved over to the 1 to get of the function what 1 was originally supposed to be given. And that's why I get that point. And if you've got the idea, you can probably fill in the table. I'm just going to keep droning on with it, though. 4 walks in as an x coordinate. Here is x equals 4. But as it gets near the kingdom, it finds out that h is only accepting x divided by 2. So it says, really, I have to be cut in half today just to see h and let it tell me what I am or who I get to associate with. So it allows itself to be divided by 2. H sees 2 coming and says, I give you 0. So what that means is when 4 goes in, 0 comes out. And I can plot the point 4, 0. And realize that on the graph over here, it is taking what used to be the point 2, 0, and it's multiplying the x coordinate by 2 to stretch it out over here to 4. Next, 6 walks over to the kingdom of h, finds out h is only accepting x over 2's today, so it has to be cut in half. Ow! But I liked being even. Why are you making me odd? I didn't want to be odd. No one wants to be odd. No, I take that back. I like being odd. Okay. 3 walks in to the kingdom of h, and h says I will give 3's that come in negative 2's. That means when I have x equals 6 on the graph, the y value will be negative 2. One more to go. 8 comes over to the kingdom of H, finds out H is only taking x over 2's today, so it gets divided by 2. I'm still even at least. It's now divided by 2 to become 4. If 4 walks into the kingdom of H, H says, I allow you to have -4 as your rations. So 8 goes in as an x, -4 is the y that it gets. And that is right over here. And now I'm going to draw what happens to a graph when its x is divided by 2. When its x is divided by 2, I actually take every x and I multiply by 2 and I stretch it out. The only one that doesn't change is when x is 0, because again, if you take 0, divide it by 2, it gets to stay itself and walk into the kingdom of H. Now I recommend that you watch this video a couple of times to get a better understanding of what's going on here, and we are going to keep working on this. Ultimately, what we have is when a transformation is made by, and let me just go straight to the answers. When a transformation is made by multiplying x by a number, the x coordinates of the parent graph are transformed by dividing by that number. And the reverse is also true, meaning when a transformation is made by dividing x by a number, the x coordinates of the parent graph are transformed by multiplying by that number. I hope this helps, but again, you may need to watch this video a few times for this to begin to make sense. This isn't simple stuff. So I will see you online. Goodbye.